You're all here to learn about TypeScript. I already went through the spiel, but some people have come in. If you have any accessibility needs, if this doesn't work for you, you can take a picture of this and you can clone the repo that we're going to go through today, and you can look at all this yourself. Also, if you're curious, you think I'm wrong, you can clone the repo and prove me wrong in real time. It'll be great. But yeah, so today we're going to do TypeScript deep dive. You may be asking, who's going to be telling you this? My name is Goble. My pronouns are he, him. I'm a boot camp grad. Do we have any boot camp grads in the house? Yeah. Traditional degrees. Yeah. This is my 5th conference talk. I have this in. Yeah. Thank you. You read. This is the first conference I ever went to. This is the first conference I ever spoke at. And this is the first talk I ever did, with a little bit of additions for the modern era. When I did this originally, TypeScript was like, I was just an Angular developer at Home Depot, and I hated TypeScript, and it was just the worst thing that ever happened to me. Then I realized that like, I hated it because I didn't really get it, and I was just trying to force it to do what I wanted to do because I was trying to get my story done, etc. So I did this conference talk mostly because I had gotten through a lot of stuff, and I was telling my coworkers like, hey, if you just do blank, if you just read it, it starts to make a little bit of sense, which I think was more for me than them, but who knows. And that's what I want to go through today. I also forgot to mention, I guess, that I'm at Microsoft right now, which is cool. If you're interested in that, talk to me after. And also, you can follow me on Twitter. You can ask me TypeScript questions. You can see me make bad jokes at Goble. So what are we going to be doing today? I can tell you what this conference is not, what this talk is not. I'm not going to be selling you TypeScript. This was a funny slide at the beginning because like no one was using TypeScript. Now it's kind of a joke if you're not using TypeScript. So I definitely don't have to sell you on it. You're all here because you know it and you're probably using it. Show of hands, who's actively using TypeScript today? Yeah, that's a lot more than the first time I talked about this. And we're not going to be going over what a number is, how to make a string. We're going to be, the goal of this is essentially, I'm going to show you some scary TypeScript types. They were scary to me at one point. I bet they're scary to some of you. We'll see. And we're going to try and learn some tools to break those down and actually be able to understand them. So we're going to learn all of these things. We're going to learn intersection types, union types, generic types, map types. We're going to learn some types. We're going to learn conditional types. We're going to learn what infer is. I think that's like the thing that most people get out of this talk. And we're going to go through some real world examples. We're not going to be like, it's a cow. It has moo. However, I do think I actually literally have that. Any questions? I don't think so. Okay, here's where we get into the handholds. Raise your hand if you've ever written TypeScript again. Come on. I know you have. Okay, we're going to keep our hand up, and you're gonna put your hand down once you don't know how to read one. Who knows what this does? Okay, good for you. Who could tell me, don't tell me. That's my job. Who could tell me what this does? Okay, pretty good. Does anyone have an idea what this would do? Okay. Can you infer the meaning of this? Yeah, it gets a little tricky. I definitely couldn't off the top of my head. So, by the end of this talk, I have a good amount of faith that we can at least get to this one. But hopefully we'll get closer to the other ones. To do that, we're going to learn some tools. The first tool, and I think the easiest but one of the most nuanced, is union typing. Union types describe a value that can be one of several types. A very good, real example of this is out of the Typefest library. It's an open source type library that I really recommend you all look at. It was a big inspiration for this talk. Is like a primitive. Sometimes you got to tell your code, this is a primitive. It is not an object. It's not an array, but it is either a null or an undefined or a string or a number or a boolean or a symbol or a big int. Great example of this is hello is world. That's a primitive, but so is big old number. Is object a primitive? Obviously not. TypeScript here telling us that. How nice of it. We're all kind of on the same page here. We've seen this. This is probably pretty introductory at this point. But then we get into key of. The key of operator is a way to make union types. It generates union types from more complex types. For example, if we have this user here, has a first name, a last name, an email, and an ID, if I use key of user, I'm going to get the properties of user. It's going to be a string literal of it's going to be a string literal union of first name, last name, email, and ID. So if I this type is kind of not useful in and of itself, right? But if I were to happen to say, is stuff a user property? No, you goofy. Because it's key of user. You can do that, and then also in a more real world sense, we use string literal unions every day when we have string arguments, when we have number arguments, like buffer encoding. You can't encode a buffer any which way. You can only do it these ways in Node. So, hello Connect.Tech, if I make that a new buffer of ASCII, that's going to be great. That's going to work. Thank you. This has been deprecated since I last gave this talk. That's rough. But if I try to make a new buffer of please don't ask me about buffers, I just know about types, it's going to say, what are you talking about, man? That's not a buffer encoding. This is one of the many ways TypeScript helps us. If we have any nerds in the room, I'm about to upset them. Another common number literal union idea is a dice roll. It's 1, 2, 3, 4, 5, or 6, but if I want my dice roll to be 20, sorry nerds, that's just not in my dice roll. Any questions on union literals? I'm going to be asking any questions a lot. Please ask me a question. It would make my day. Maybe not yet. I haven't done anything interesting yet. But, so yeah. The next tool we're going to need to diagnose and slice up some of those types is lookup types. So this is also known as indexed access typing. This is a lot like in JavaScript or TypeScript. If you have an array and you want to get a certain part of that array. So ABC sub 1, we all know it's going to be A. No. Whoever said no, thank you. So we go back to our same user, and we have first name, last name, email, ID. And a lot of people, you're in your TypeScript types, and you're like, oh, well, this thing is going to be part of this object, and you're just going to set oh, well, it's just a string, so I'm going to say ID is string. But in reality, ID could change over time. ID could be a number and go to a string. You could make a new type for a UID and make that type. So you can build associations in your types with index access types. So for example, if ID is number right now, and I say type ID type, I use an alias here, and I say ID type of user ID, it's going to give me number. But once again, if I change this to string, ID type, magically string. No more fixing errors, no more uncongealing your copy paste all over the place. If you just link your types together, you'll get some access there. What's cool about lookup types, and what I think will start to kind of blow our minds, is that they can also generate union literals. So user subset of ID and email is string. But if I change this back to number, then we'll see that it's a string or a number. Because it doesn't know, it just knows it's going to be one of those two, right? That's what we're telling it. A cool use of index access types is figuring out the type of an array. So if I have Twitter users, oh, I took the part out of the solve. We're going to go to, it doesn't matter, I'll do it live. So Twitter users is Waller Goble, ID, leet, overall's true, or we have a much less good handle. We've got Quelch, ID 404, I don't know where he is, definitely doesn't have overalls on. We can say that Twitter users equals type of Twitter users sub number. Because we did an index access lookup of number, it now knows that my type is handle string, ID number, overalls Boolean. Pretty cool. Here you go, Kyle. You can take a picture of your ID. Any questions on that? I think that blew my mind when I thought, oh, we got a question.
Can you look up like a complement So it's a union of property names, and you ignore property names in your type.
I mean, yeah, so I could look up like this sub. So the question is, can you look up other parts of a lookup type? Is that kind of the idea? Oh, see, you're getting there. Don't worry, we'll get to you. Your question will be answered, I can promise you. Any other questions? Cool. We're flying through, we're moving on. Ooh. So the opposite of, maybe not the opposite of a union, is an intersection. Intersection is the combination of multiple types into one type. This one also has like, it's a less fun by itself, but also can be transformed into more behaviors together. So this is a function merge, where it takes in a t and a u and takes one object, another object, and then most importantly, returns the intersection of those objects. In JavaScript, this is fine. We do this all day. This is a spread operator. This is fun. But the merge object is the result of that. So we can see we get a new type. It's going to be both an object with the name string and an object with the number with age, which is a number. Intersections are going to become pretty important in those types we saw back there. So the first one that I think is like stumbles people, we got generics. Who thinks they have a really good handle of generics? They don't need to be here. This is going to be great. I know you don't. We've been through that. Yeah, generics I think are where type systems start to get like, oh, this doesn't feel right. But generics I think can be easily explained. Generic types provide the ability to make reusable, parameterized types. Functions, but for your type system. They take in arguments and give you a new type. So the easiest generic function in the world I think is an identity function. A function that takes in t and it's like, so it takes in t. It's like, I don't know what it's going to be, but I know that you're going to give me t at some point. And I know that my arg is going to be t, and I know my return type is going to be t. And that's because I'm just returning arg. So the reason generics are powerful is because I give this a number, it's 1. If I give this a string, it's a string. If I give this an object, it's that object, right? For here, we're giving it handle, wall, or Goble conference talks about a fourth of the way. Why t? There's no reason. It's a convention. It means nothing. You don't have to put t. If you take anything away from this, it doesn't have to be t. You can give that a useful name. We'll go into some possible useful names in a little bit. You use generics every day if you're using Typescript. I think the easiest one to see is record. So a record of strings to objects is an object map. A record of strings to numbers, that's a number map. Record of string to any, I hope you're not doing that, but that would be an any map. And so you can see, this gives you the facile type safety of O string string. If this is a string to string map, well, I can't have my numbers in there. That's going to mess up. Generics can also have constraints. So if you remember our cool thing we did before, with a generic, we can genericize that and give us a get array kind type. This type will take in a t that extends array of any and returns us t of number. So we get back to our example before, instead of just inlining and knowing that little hack that we can do number, we can make that generic and find our Twitter user that way. Get array kind of type of Twitter users gives us that same object back. But that constraint works, right? We want TypeScript to yell at us. That's like its whole job is to yell at us when we're done. Maybe misunderstanding is a better way to put it. So number maybe, it's just going to yell. It's like, what are you talking about? That doesn't satisfy the constraint of any array. Any questions about generics? We're about to really get into them, so if you're confused now, it's not going to go well. Well, we have a bit of a respite from it. So we have map types. We're going to turn on word wrap. Oh, no. Word wrap, yep. So map types are departures from generics, but they're another useful tool. And there's something I don't feel like other type systems have, like, I've never really encountered other type systems that do this easily. So map types create a new type which transforms each property in the old properties type in the same way. It's like a for loop for types, much like we've had our indexed access, we've had our functions. This is our for loop to iterate over types. And that's weird. You think you don't have logic in your types, but I guarantee you do. So the most useful example, nullable exists. You've used this before, possibly. It's a built-in type. But how is it implemented? It's implemented like this. Nullable takes in any t, any object, and goes through each key. And how it does that, it says p in key of t. So what this says is like key of t is what I'm iterating over. Excuse me. So that's the type. I'm getting the keys of the type, and then I'm iterating over them in, and I'm setting like the var blank equals for of whatever. That's p. So p is my property name. So I'm saying nullable of t is t, but for everything that is t of p, so we're using our index access types, t of p is equal to t of p or null. So that's going to go through each of these and say like, first name is going to be whatever first name was or null. Last name was or null. Email was or null. It's going to end up with something like this. So while with parts missing, I have a first name. I don't have a last name all of a sudden. RIP. That is my email. I really got to take that out. And I have an ID. But so I can't do this. And like a lot of people, a lot of new TypeScript people are just going to make another type and be like, user without last name. Don't do that. Make a nullable user. And then you can make, like if you use nullable of user, we don't have an error here anymore. And we can even modify this object. Any questions there? Does that start to make sense? I think that's weird. You look a little confused, maybe skeptical. We'll find out. So you can do a lot of strange stuff in map types. I think it's kind of strange what all you're allowed to do. There's a lot of stuff that I don't think is very documented. Question mark you probably know about. So user with optional properties would be something like this. A less savvy TypeScripter might go in and just make this type, make my optional user. But who has time for that? We can go in and do the same thing. We can say, for key of t, I want to iterate over it and make it a p. And I want to make that optional, or t of p. So once again, we have the same thing. I want to just leave out one of my properties. I'm feeling lazy today. I don't feel like talking about my last name. So while with no last name of partial lets me do whatever. Don't have to have any of it. I can even just delete everything. That's true. That satisfies the constraint we made in our map type, right? So that one's, you've seen question mark before, but have you ever seen read only? Maybe you have. The read only modifier makes it to where you can't edit a property. So this is really useful. I use this a lot in my types because I don't really like modifying my objects, the whole functional programming thing. We're not going to get into that. But if I make a read-only user, no one can rename me to Wilma, as hard as they try. And we get the same error. We just get read-only, but we never use read-only. We just used our map types to modify our internal domain objects. The cool thing about these, much like functions, we said generics are functions, right? Well, functions are composable, so are generics. So I can make a partial nullable read-only user. So it can be null. I mean, it can be whatever it was. It can be null. It can be itself, or it can be undefined. But I can't change it because they're all read-only. So this is where we start to get some power. If we map, it's like how we can make individual functions and compose them together. We can make individual types, compose them together, and make our types do exactly what we want them to do. This I learned while doing this. I was just reading through. Oh. I would never make a partial nullable read-only thing. That's goofy. But I have composed map types before of other things. We're going to see some more interesting map types in a minute. These are obviously like really wholesale flat examples, but we're going to see there's some really nuanced ones that you might want to compose. Thank you for whoever pointed out that question, and thank you for asking. So Yeah, I learned this when I was looking through the TypeScript source code for this talk, that there's just like, you can just minus stuff. So if you want to get rid of a read-only, you can just minus read-only in TFP, turns it into mutable again. Like it removes read-only. And I think that's really strange. You can also, though, like, there's also plus, which I can't actually imagine a usage for. But that would be immutable, right? But, and I don't really have a usage for plus, but it does exist. I think it's an interesting thing. So, what can we do with map types in practice? Have you ever used pick before? This is a built-in type in TypeScript. You might have wondered how it's made. So pick says, give me a type and give me keys that generally extend key of t. They have to. That's a constraint. They have to do that. And for p in the k that you gave me, give me t of p. So if we have type user name and ID equal to pick of user, and then a string literal of name ID, right? Now we only have an object that has those two things. So map types, a lot of them have surfaced to you from these general types, but if you want to start making complex types, you got to understand what's actually behind the scenes there. Any questions on map types? Oh.
You have a map type like nullable, and let's say you wanted to make this might actually be related to this question, but you wanted to make every field nullable except say like first name. Would you use more of a condition or a pick? Or what that work?
Oh, much like your friend over here, that exact question will be answered soon enough. I think even in the next slide. Let's find out. No, you're not going to learn about that yet, but close. We will get to that, I promise. So we're going to stop and we're going to do some learnings. We have one of those types in front of us. We actually have two of those types in front of us that we said we understood perfectly. We're going to see if we can understand them now that we understand map types, generics, string union literals, and indexed access. So if you'll say remember me, which is t, k extends key of t, and is equal to a pick of t, but the keys are the exclude of key of t of k. That sounds ridiculous. But if we are the Typefest library, which I pulled this from, and we have great documentation, and we write code that's for humans, not computers, which we should all do, we can see that we can make that a lot easier. We can see that except takes an object type and a keys type, which extends key of object type, and gives a pick of object type and exclude key of object type of keys. What does that mean? It's like pick, but it's the inverse of pick, right? So I want all the things except one. So give me user without ID. Now I just have first name, last name, email. Now you've got your view model object right there. You don't want to show the user ID, but you do want to show the fields, right? That's crazy. All of the power of generics. So we've got another one. What does this do? T of k extends k of t equals k of t equals key in k, blah, 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 blah. With some extra characters and some love, we can see this is require at least one. So what this does is it takes in an object type and a keys type, which extends, it must be at least the keys type, right? And it says, for each key in what you passed in, make a map type. So for key in the keys you passed in, make those keys required and only choose the pick of the object type of that key. So grab just that key, grab what it gave you, and make that thing required. And make an object of those things that must be required. Now look that up to only the keys that I passed in. Index, give me only those properties. And intersect that with the exception of the rest of my keys. Did that make sense? Did we learn something? Yeah, I know, right? I don't actually expect you to read this and understand it. It took me like a month of really trying to learn this stuff to do it. But the fact of the matter is, in our daily lives, you know, you're like going through some random type library and some like React @types package. You have no idea what's going on. Typescript's yelling at you. And you look at something like this, and maybe it looks like this, or maybe it looks like that. But we need the keys to actually pull these things apart. And now that you know map types, index access, and intersection, you at least know what half these like symbols do. So in the end, this makes a require at least one type, which is really cool. I'm sure I've run into this. I like found Typefest because I wanted this exact type and I couldn't figure out how to write it myself. So what this does is something like, okay, give me an object, any object, and give me a set of fields, and I'll make at least one of those required. So I need JSON. It has to either have text or JSON. If I comment out JSON, this is not valid anymore. It says I need at least one. Typescript doesn't give us a nice error. What a surprise. But at least it yells at us. But I can still have text as well. Yo. And that's fine. And I can comment out JSON, and it'll be fine. But if I comment out text, it doesn't work because it requires at least one. This kind of goes to, I think, your question of how to do things in a subset, but I think yours is going to be more of the next example we have. Any questions on this? Does this make sense to y'all? You're learning something? Is this feeling a little like, oh, I got to go home and learn TypeScript. I actually don't know TypeScript. Yeah. Cool. Okay. So we're going to keep going. And I think the next part of this is actually substantially more hard to understand than what we just got through. But don't worry, we're all going to understand everything perfectly. It's going to be great. Conference talks are for completely understanding every single thing that's said. Right? Right? We'll find out. So, never. Has anyone actually ever used never? Has anyone never used never? So never indicates an impossibility. And I wouldn't expect you to just use it in your everyday life. I've never written, outside of right here, I've never written this code that actually uses never just by itself. Much like all these other things. I don't use them by themselves, I use them together. So never indicates an impossibility to the type system. It says, hey type system, just stop listening. This will never happen. I don't want to use this. If I've gotten here, I've messed up. So technically a function that only throws and does nothing else is a never, right? This is never going to return. I can even take this off. I don't want to. I can set something equal to never. I can say it's the type of never, but then I can never use it. It's like, well, this is great. Thank you. Thank you for yelling at me, TypeScript. I'm really enjoying this. Never useful. But never is very useful in the context of conditional types. So conditional types, we've learned about looking up in an array. We've learned about functions. We've learned about iterating. You didn't think you had this much logic in your types, but you also have ternary operators. Not only that, you have nested ternary operators, your favorite kind. So conditional types express non-uniform type mappings, if you like math. But in reality, they select one of two possible types based on a condition as a result of a conditional logic. They follow the pattern of T extends U, if so, X, otherwise Y. So we can write our exclude type that we've been using before very simply. It takes in one type, it takes in another type. If the type passed in extends the second type, then we don't want it. Otherwise, we do want it. So in a very useful, oh, I hovered over it and gave the answer. Anyways, what's this going to be? If we exclude 1, 2, 3, 4, and we exclude 1, 3, it's going to be the even numbers. And it's because each one of these is going through. It's saying, is 1 in 1 and 3? Okay, get rid of it. Because it's saying, is 1 in 1 of 3? If so, never. I don't want it. Is 2 in 1 of 3? No? Okay, give me 2. Is 3 in 1 of 3? Okay, I don't want it. 4, etc. I wrote this because it looks not like valid code. It looks awful. As always, we're gonna give a more useful example. In user properties, if key of user, and I go through and I exclude key of user and ID, then I'm gonna get the properties without an ID. Whoever asked the question of just setting one equal, or just setting one null, you're about to be very happy because it's kind of getting towards that point, if you'll notice. We've figured out a way to get certain properties, but not other ones. Any questions on conditionals by themselves? They're not really exciting by themselves, but they're extremely exciting in terms of infer. This is where things get crazy. Someone told me to add more emojis to my slides. I don't think it works. Infer is pseudo pattern matching on types if you want to be a nerd. In reality, much like we have all our other logical features, infer equals let var const. It lets you set a variable in the middle of your insane logic that you've decided to include in your type system. So these exist in TypeScript already. We're just going to show you them as a way to understand, like, oh, infer can be used succinctly. So what if I want the return type of a function? T extends, we get a constraint of a generic, says this extends args of any array. So just any function you can throw at me. If it does that, if it extends any array, that's the if, then infer R. Set whatever would equal, like whatever would go into that slot. If that's true, capture it there in my return type. So I've just slotted like whatever the return type was, of if the first thing was true, capture it. And if so, if that is true, return it to me, give me R. Otherwise, why would I care? Never, 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 never. Please don't let me do that. So what does this mean in practice? If I have a predicate, which is a function that takes in whatever and gives me a Boolean, I don't care about this. It could be anything, but I do care about Boolean. But if I get the predicate return type, and I use like return type of predicate of any, because I don't care about any, this could be number, right? Then, predicate return type is Boolean. That's rad. We just set a variable. Shouldn't be able to do that in your types. It's crazy. Woo! No, I know, it's 10 a.m. However, as we said, this is like a ternary operator, right? So we can get into the other conditions. So if we just pass number into return type, what is this going to be? Never. What about if I make a function that triples things? I'm using pedantic examples. We see that number takes in number and returns number times 3. Well, the return type of this is number. If I put in return type and I use type of triple, I'm going to get, not 9, but a number. It's rad. So we kind of hammered that home. Infer is going to feel really complicated in a second when we get a huge block of text, but it's just setting a variable. So does anyone use tuple types? I feel like I use them sometimes, but they're kind of cool. If I need the first thing of a tuple, I can make a type that calls first. And if T extends any array, so the thing I'm passing in extends any array, which all tuples technically do, right? If it does, T extends, and then once again, we're setting up this capture point. It extends an array, and I'm inferring the first thing in that array, and I'm using the spread operator to capture the rest in a place that I don't care about. You've got spread operator in TypeScript, who knew? In the TypeScript types, obviously you have it in the language. If that's the case, if I have captured this successfully, gimme. Otherwise, I don't care. So, in tuple, if this thing just returns things as a tuple, right? So my tuple of A1 true, what's this going to give me? String number Boolean. So this thing, my tuple type gave me a tuple type. My tuple function gave me a tuple type. But if I use the first of my tuple and I use first on type of my tuple, I'm going to get string. That's rad. We're extracting we're extracting types from our logic. So we don't have to, author a bunch of extra types. We can just bring that stuff back in. In practice, it looks a little more like this. Do we have any Next.js users in the house? Just 2? Wow. Must be nice. I'm over here working on not Next.js. put it nicely. So you may have used the infer get static props type that's in Next.js. So what this does, it says if t extends the get static props type of infer p. So like if the t extends this, grab the first generic of whatever I passed in. I put any because I don't care about any. And if so, give me that p. Otherwise, nested ternary, what if t extends a function that yields context of get static property context and returns either a promise of get static props result of infer p or just get static props result of infer p. Either way, give me p. So this type is just like, what? 10 lines of code? But this is like the thing that gives you type end safety in Next.js. That's huge. That's like a big part of the value they provided, and they did it with 10 lines of TypeScript and using our tools that we made. So this has generics, it has map, well, it doesn't have map types. This only has generics and conditional types and infer. And you could have done that if you worked at Vercel. Inspirational. Something we're all familiar with, I assume we have more React users than Next.js users. Anyone using that small library React? Yeah. Someone is. Well, I'm sure you've had the annoyance of like you're trying to spread over your props, but it's like, you don't have ref defined here. And you're just like, I don't care React, please just give me the props without ref. You use this type, right? So this says the props with ref is p for props. And it says if ref extends key of p, so if ref is in the key of p, then also what if p extends an object with ref, infer the ref type. If it does, then does string extend R? The thing I captured. If it is a string, then it's props without ref of blah, 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 blah. And it just says, hey, get that shit out of here, right? It's kind of laborious because we only have these small tools because we can't just embed like logic in our types because then we'd have logic in our logic and logic in our types and that'd be annoying, but we do have some logic. So yeah, this is in Types React. When they were typing React, they had to figure this out and they had to model the existing behavior of the JavaScript in TypeScript. And to do that, they had to jump through some hoops, literally and metaphorically. Any questions on infer? We all get infer perfectly. It makes perfect sense. We could all go home and do this at our teams. We're going to tell our teams about it. I thought so. So, we're going to do our last learning segment. I think we're doing right on time. Yeah, we're good. So, we learned again. Generics, conditionals, infer, oh my, this made me laugh at 6 a.m. today. So can you infer the meaning of t of k extends k of t equals k of t equals pick of t exclude k of t of k intersected with a partial of pick of t of k extends infer of u of blah, 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 blah. With some love, once again, if you take anything out of this, don't use t, don't use u, don't use k. That's just violence against your coworkers and your future not coworkers. We can make a type. This answers our friend over here's question. That's sets optional. So given keys, it takes a type and gives those given keys optional. It makes the rest not. So for set optional of base type and keys extends key of base type equals to key of base type. So for all of them, give me the intersection of all the types that I don't care about, right? Like all the ones that I don't care about that are not optional, give me those, and intersect that with a partial of the types that I do care about. And if that extends infer, if that extends capture that, so we're just using extends here to capture that type that we care about. If it does, map over that inferred type and make those things optional. So for my friend that wanted to make one thing nullable, you just pop this and make it or null here. And that would make it work. Or never, right? So what does that do in practice? If I have a type foo, I got lazy here apparently, and said A, B, and C, and I only want B and C to be optional, and B already was optional, well, now I have a type that says A's number, but B is optional and C is optional. Crazy. And that was like, that was the hat trick, right? that had every single thing we've talked about. It has intersection, it has unions, it has map types, it has infer, it has generics. This is like the magnum opus of this talk. So yeah, you learned it. We go back to the intro. You guys now know advanced TypeScript. You've done a deep dive. Give yourself a round of applause. So, I've given this talk a couple times now, and people just ask me a bunch of things, and I want to address those. But right now, do we have any questions on, like, we learned this, we got this? Do we have any questions on what we've learned today? Yo.
It's not really a question. I just want to comment that I appreciate the format of this presentation all being code, and that you gave us the repo, so we can, like, I'm going to use this more of a reference document going forward, so I just appreciate that. And wanted to call out that that's really neat and cool.
Thank you. Can you imagine how scared I was in the keynote when I was watching it go out for 10 seconds, every 10 seconds? I was completely ready to like just sob through this. But I don't know if you noticed the difference. I got a Dell. No MacBook Air, no M1. This thing works. Just saying. Just saying. Yeah. Lone person clapping for Windows. Not even the Microsoft employee behind him. Oh, that's rough. We're having fun. So, thank you. I think that's cool too. I think the most important thing about this talk is giving the things at the beginning. I think it's really important to make talks accessible, because obviously if you can't see very well in this like arguably well contrasted theme, you're not gonna be able to see this well. So I think meeting people where they are and being able to see the slides is really important. If any of y'all want to give a talk in the future, I'm happy to talk more about how I try and make my slides help people. But we're gonna go through a couple things, then we're gonna hang out. So I think the number one question like my coworkers ask me is like, you see, you thought I was talking about you, I was talking about her. Like type versus interface, what do I do? Why does it have two of them? I don't have a good answer for you, but I do have my answer for you, which is what your employer paid so much for. What's the difference? Type is useful for type aliasing. You can't alias types with interfaces. So you can't do any of those like cool generics where we blah, 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 all that stuff out. You can't do that with interface. It's also less characters and makes me feel like I'm writing a cool functional language. And that's why I use type all the time. And also because all these complex types generally are of type. The con is you can't extend. You can't intersect as we learned today, but you can't extend animal type. So animal type has legs and a diet, but I can't extend lion to give it like main, true. Interface can use the extend keyword in the definition of the type outside of a generic. But it's like so many keys, it makes me feel like I'm writing Java or C# now. And that hurts my soul because those languages aren't as fun as TypeScript, I'll say it. But I can extend lion and make it sound gur, which is like a contrived example, but it's important. My recommendation is like, if your team is already doing something, it doesn't matter. There are some people that will tell you there's like some performance implications because there's like a blog post from like 2019 that said that. That's not true anymore. So just stay consistent, do whatever your team's doing. It really doesn't matter that much outside of the places where it actually matters. My other two main things I want to talk about, and this is like, I think this is the most useful slide in this talk, right? Because this is like the elephant in the room of TypeScript. Well, does it mean anything? We've got any. So I think any is extremely useful. I don't write any every day, but I do use any every day. So as you all know, any says like, I don't care, man. My PM's yelling at me. I have to get you to stop yelling at me. I can't handle both of you, and I get paid for her to yell at me. I love my PM if she sees this at any point. Anyways, so yeah, it's just an employee, but I don't care because it's any. And it's a keyboard jockey, and it's blah, 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 blah. And if I use that, I can set this equal to Boolean because get property returns any. TypeScript will stop yelling at me, but in reality, I'm less sad. I'm more sad at the end. So don't just throw any around. Trust me, that's another violence against your coworkers. It just makes you sad. But I do understand we have to get code done at the end of the day. We have to push our stories. We have to do this. So what I recommend is making a type alias. I got this from, I don't think I've added it to the sources yet, but this is one of the best things I learned from a really good talk by, I think her name was Bree at Airbnb, about how they TypeScriptified all of Airbnb in like a couple months. It's a really inspiring talk. Just set an alias that is like really annoying, like $fix me. It's like just screaming at you that you've done something wrong and that you need to go clean it up. It's like a type level to-do statement. And just put that there, move on with your day, and then on Friday when you should be working but you're not really working, you go back and fix that. This is like, if you go and add anything in this examples to your code base, I recommend this line. And it just helps. I use it, like, this is the prototypical. If you look at like a project that I did do in a week, this is the #1 thing you're gonna see, right? I don't care about my props. I want to pretend it's like 2014 again. Just let me type. But that being said, there are cases where I use any. I don't know if y'all have ever used Ramda. It's like Lodash for nerds. It's a very functional compositional library. If you ever use the compose function like this is the straight out of the Ramda @types package. And a compose function essentially takes in a bunch of functions and takes in the parameters of the first one and gives you whatever the compose of the thing that the last thing returns is. So that makes sense for one. If you compose one function, you're gonna get whatever it takes in and gives you the result, right? V0 on that. But what if you have 2 things, or 3 functions, or 4 functions, or 5 functions, or 9 functions, or the max that it allows, which I think is 12. So this takes in the beginning, any's the middle, and works on the end, because that's all that really matters, right? It's true. It doesn't matter what's in the middle. It just works. So this is an example of a real any. It's like, I truly just don't care what this is. Let me work. So that's any. In any other situations where fix me doesn't work and you don't know what you're going to do, TypeScript, recently as of this, the original talk, but not recently. Y'all probably know about unknown. Unknown says like, hey TypeScript, you may know what you're talking about, but I definitely don't know what you're talking about. So let's make us both be a little safe. So it says the compiler makes you requires you to like justify any usage of this. So for obviously a number, we know that it's 5, but we've told TypeScript, hey, don't trust me. I don't know that this is 5. And it trusts you. It's like, hey, if I try and use add, you can imagine what add does. But it says, hey, you can't add unknown to this. It's not a number. But if I prove to TypeScript that it is a number by saying if type of obviously a number equals number, then it lets me use it. This is much more interesting in, this is all just boilerplate. You can imagine that this works. But if I'm throwing an error that can fail, this is a really useful thing that I'm sure you have. If you're using strict mode, this is already turned on, I think. But if you use the compiler option, use unknown in catch variables, then all your errors will be unknown. And that's because all your errors are unknown in JavaScript. You can throw whatever you want. It's not real. Nothing's real in this language. Nothing makes sense. But this compiler option makes you make sure that you really know what you're doing when you're catching something, because you have to. So I can't just console.error.message anymore. I have to prove to the compiler that it's an error before it lets me do anything. And now TypeScript is happy. I can use my error.message. An example of like, you don't really know what's going on. Here I'm throwing a promise. You can do that. It's fine. And I'm catching unknown. Normally I call this error, but putting error here is a little lazy. And it just won't let me do it. So just a little word to the wise. Use unknown if you really need to, and unknown is most useful in this use case. And that is about all I've got. Thank you for listening. I have one last word for you. Jamie Kyle is someone on Twitter. who I really look up to. And the day before the last time I gave this talk, he tweeted this. And I think it's really important before you go home to your teams and be like, guys, you'll never guess what I learned. We gotta type everything crazy. I think there's a lot of use in this. I think he's spot on the money that you don't want to go crazy with these features. But as always, learning is always going to make us better developers. And I think learning these things can really just make you understand and be more productive. And sometimes you have to write something crazy. And in that case, now you know how. So yeah, that's all. Thank you so much for listening. Thank you, Pratik and Vincent, for putting this on. And thanks for Jeremy for giving a really great keynote. I would really appreciate it if we all just like went in our pocket and grabbed out our phone and took a picture of this. This is a link to a Google form. If y'all want to give me feedback, that'd be really cool. I've been giving a lot more talks lately, and I think it's really helpful when, like that guy said, this is a really useful format for him. It's really helpful for me to hear that. And I think that's it. And yeah, if you download these slides, I'm not going to scroll to the bottom because I want you all to take this picture. But there are my resources. There's things that I find cool, things that I go to when I learn TypeScript or when I'm trying to help other people learn TypeScript. Lastly, I forgot to do this at the beginning before I bored y'all, but I'm going to take a picture. So everyone say cheese or get out of it if you don't want to be in it. Run. Okay, please clap. We're done.